Welcome back to the channel. In today's video, we'll show you how to determine whether the thickness of a concrete slab is sufficient to resist the applied loads. A one-way, simply supported single-span roof slab spans 5 meters on a one-story building. We need to determine whether a 200 mm thick concrete slab made of C30 concrete can resist an ultimate bending moment of 35 kN per meter. Assume the cover is 25 mm. As a result, effective depth equals 200 mm, minus the cover 25 mm, minus half the diameter 12 mm. This results in a value of 169 mm. So, the first step is to use these equations to calculate the lever arm. Therefore, K equals bending moment, 35 times 10 to 6. To convert the bending moment from kilonewton-meter to newton-millimeter. Divided by the width, which is 1000 mm, divided by the effective depth 169 squared, divided by the strength of concrete of 30 Newton per millimeter squared. As a result, K equals 0.041. Z equals the effective depth times 0.5 plus the square root of 0.25 minus K, which is 0.041, divided by 1.134. This corresponds to a value of 0.96, multiplied by the effective depth of 169 mm. With 0.96 being greater than 0.95. As a result, Z equals 0.95 times effective depth 169 mm, which equals 160.55 mm. Using this equation, we should be able to calculate the area of reinforcement required in a concrete slab to resist tension due to bending, which is equal to the bending moment, 35, times 10 to 6, divided by 0.87, divided by the tensile capacity of the steel reinforcement, 500 newtons per millimeter squared, divided by Z, 160.55 millimeters. This corresponds to a value of 501.2 mm squared per meter. As a result, we should use H12 bars at 200 mm center to center, which equals 565.2 mm squared per meter. Finally, we must examine the serviceability. The magnitude of deflection for reinforced concrete is difficult to determine because it is a composite material. As a result, the concept of allowable span-depth ratios was developed, which eliminates the need for complex calculations. Modification factors can be applied to this basic span-depth limit. These factors are determined by the amount of stress, tension, and compression reinforcement is subjected to as a result of loading. The equation used to calculate the modification factors is affected by the tension reinforcement ratio in comparison to the reference reinforcement ratio. This equation should be used if the tension reinforcement ratio is greater than the reference reinforcement ratio. Otherwise, we must use this equation. Tension reinforcement ratio equals the area of reinforcement required, 565.2 mm, divided by the width, 1000 mm, divided by the effective depth, 169 mm. This results in a value of 0.0033. The reference reinforcement ratio is equal to the square root of the concrete strength, 30, divided by 1000. As a result, the tension reinforcement ratio is lower than the reference reinforcement ratio. As a consequence, we should use this equation. Therefore, the allowable span per depth ratio is 33. This value must be compared to the actual span per depth ratio, which is slab span, 5000 mm, divided by effective depth 169 mm, resulting in a value of 30, which is less than the allowable ratio of 33. Therefore, the slab depth of 200 mm is deemed satisfactory. Thanks for watching. We hope you found some useful tips. Check out our website at structuralengineercalcs.com. Please like and subscribe, and let us know what would you like to see next. The human footprint is a masterpiece of engineering and a work of art. Stay safe. Goodbye, and see you soon.